ladies and gentlemen. It's my pleasure to introduce you our honorary keynote speaker, Professor Volker Gruhn. And Professor Volker Gruhn is more than friends, in fact, and very great person. He is the chair of software engineering at the University of Duisburg, Essen, Germany. And as you see, his field of research, but most of the thing, he is a successful businessman. He is the founder of Adisto, which is a big company now, and he founded in 1997. And now there are about more than 3,000 persons working in the company. And I'm very honored to have him here with us as a keynote speaker, enlightening the conference with his idea about the new school of IT, the new paradigm of IT organization, and how it contributes to engineering data-driven systems, which is very, very important topics, merging artificial intelligence with software engineering. Volker, the floor is for you. And thank you again for accepting our invitation to give the keynotes. So please go ahead.
Yeah, Islam, thank you very much.
Pleasure.
Welcome everybody. Good morning or good afternoon. For me, it's good morning. For you, it's good afternoon. It would be so nice to be with you in person. I remember last time when Summit took place in Kita-Kyushu, we had a great time, and I would have very much appreciated to be there in person and not only digitally. But well, things are difficult in these times, and so we have to look what's possible, and hopefully there will be another opportunity to meet this great community and to meet these great Japanese places at the next time. So today I'm trying to give you an impression about what our new school of IT means. And that is not a purely academic approach, I'd like to say. It's something in between academic experience, which are, as Isam already told, from the background of University of Duisburg-Essen. And of course, the second dimension is that of a commercial software development company called Adesso in this case. That doesn't play much of a role, but of course, I really would say, of course, both perspectives play together. So this role model of a new school of IT, this idea of a new kind of organization, in particular for developing and engineering data-driven systems, is determined and influenced by both sides. It's an academic perspective. In the academic perspective, the focus is on software processes and software architecture in a purely academic way, as you know about all these conferences and papers. And then there's a second dimension of commercial software development, which is a little bit more determined by, well, organization, how people talk with each other, how they work with each other, or what the general organization paradigms are. And the idea, the overall idea is that the new role model for, sorry, recording starts, nothing, I just go on, okay? The organization model of a new school of IT could be interesting to a number of companies in that context. So a little bit more systematically, we believe that we experience, it's not just belief, that we live in a world of very dense technological innovations, new technologies coming to the marketplace and being more or less proven already or at the edge of being proven, and people in industry as well in academia experiment with a number of different technologies, like from artificial intelligence in general, like telecommunication techniques like 5G or 6G, in software technology as well as in data analytics. Robotics also play a role, and all these things come together, and that seems to be new. Of course, these things are new, but I think we have never lived in an area where so many technological innovations and developments came to the marketplace in such a short period of time. And since they are can be practical at the same time, they have an influence onto each other. So we have to deal with software systems which consist of information system elements as we know them from the last decades, basically. They also have some cyber physical systems approaches and components, like we know them from the Internet of Things and Services domain. And that's most important for what I like to report today. They have also these data-driven components, which are obvious for us, like we talk about artificial intelligence and machine learning more or less on a daily basis, but which is not so used and experienced in traditional domains like banking, insurance companies, things like that. So here we see software systems are more diverse, so to say. And that's put some extra challenges to the companies and to the approaches to develop these systems. That is my second hypothesis, that these integrated systems consist of parts which are more or less well understood from the different domains, but that the engineering, the initial development, as well as operations demand for new approaches, for new role models, and for new software processes. And these processes and so on are not in place. And that is not only an abstract idea, at least it's undermined by a number of trend analysis. Here I took one from Munich Re, which is one of the biggest reinsurance companies, and they spent really quite a bit of effort in looking at technologies and when they should be used in companies, when they should be experimented with, or when they should be directly adopted. And of course, we see here these four sectors, which we all would have guessed that these are the four most important ones, like human centricity, connected world issues, whatever it means in detail, enabling technologies which are more general, and this green part of an artificial intelligence. And we see that in this sector we have quite a number of entries as well as new entries, and that a number of them are ready to be adopted, which is different to human centricity or enabling technologies. And that is also an argument to say, well, people in industry can no longer look away and ignore these opportunities. They have to check which technologies are ready to use. In the European market, this periodic system of different components from the field of machine learning and artificial intelligence has some prominency. Just recently, it's from Bitkom, which is a German association of IT companies and researchers, and they came up with such a system. And it played a role in the public opinion and in the media because it was so, I wouldn't say easy to understand, perhaps that's a little bit too much, but because it's so illustrative. Yeah, it looks like a periodic system, and it identifies things from speech recognition and speech identification down to communication control and mobility issues. So quite a different set of technologies which may play a role in artificial intelligence solutions. And it turned out to be interesting to quite a number of people, I think basically because it's a periodic system. Yeah? If it was described just as a theoretical scientific paper, people wouldn't have looked at it that much, but it seems to be interesting to more and more people. That's only to say that this development of this integrated system, in particular involving and containing data engineering or data engineered components, machine learning based components, come to the public opinion, or at least to the IT community opinion more and more. So that basically was a starting point for us to say, well, perhaps things are changing in such a quick and substantial way that it might be an argument to say, well, people in IT developing companies should behave differently, and perhaps they need a new role model. The old role model, really the very old model, where IT departments just do what their in-house customers tell them to do, well, was a little bit old-fashioned, perhaps. And things were changing already, of course. That's not initialized by this idea, but perhaps it's a worthwhile idea to give them a new role model and also to give an interesting name to that role model. And for us, this new model is New School of IT. New School of IT because we live in that, as already mentioned, world of technology innovations, and in a world where digital transformation takes place anyway and puts some challenges to companies of different domains, or letting alone if it's insurances or banks or lottery or medicine or whatever. And our belief and our experience was that if people don't understand what technology allows, they are not able to see which real world innovations are possible. And the other way around, if they only understand the application domain challenges and they don't understand what technology can help, they also don't come up with the right innovation ideas. That means people with technology expertise and people knowing the application domain by heart have not only to cooperate, but have to build very closely integrated teams. And we do not even dare to define their communication processes, but we want to ensure that they very closely interact in a particular way which is appropriate to them, which is much more than an only agile organization, because it really requests for close cooperation and and a common terminology which has to be developed. So the new School of IT is based on the fusion of technologies and application domain expertise, and it should open the door to innovation and resilience, and it is a basis for digital transformation as well. And if you talk to people, wherever, in academia or in industry, IT people tend to say, yeah, well, that's what we want to do. We don't want to be only service-oriented and tell whatever these people from the departments are telling us. But it's very difficult to really enable them to take this role because, well, to quite some extent, they are used to focusing on their IT issues and not that much on application domain issues. But well, to some extent, this challenge is understood and accepted. So we try to structure this challenge into 3 different domains, and these 3 different domains are those which I would like to discuss with you in the following part of my talk. We talk about this ambidextrous attitude. I'll come to that later. That sounds a little strange, is a difficult word perhaps, and I will tell you later what it means. That's an organizational issue, basically. And the other 2 issues are more are better known and more familiar to us. That's cloud native thinking for the architecture of software systems, and it's a data mindedness for the whole of an organization in terms of thinking what could be done with data which are available more or less anyway. Okay, let's come to these 3 different domains. First of all is the ambidextrous attitude, and well, a little bit of a marketing slide. The demand is that the IT departments should take care of robustness, resilience. They should be functional, innovative, and all that at once. Most companies I deal with do not both of these things. They have what they call a chief information officer or a chief technical officer, and he or she is responsible for the robust and resilient systems. Big and hard to change systems with rather complicated change management processes with precisely defined service level agreements of 99% of availability and things like that. And that's a traditional benchmark and the traditional key performance indicators a CIO is measured against. That is what he has to take care of. And on the other hand, and that's a new element in these organizations, they have what they call a chief digital officer, for instance, or a chief data officer sometimes. Mostly it's a chief digital officer, and he or she is responsible for the innovative elements of a strategy. He comes up with, well, machine learning based systems with natural language understanding, generation based systems, or whatever an innovation could be in a particular context. And these 2 guys are set up as peers. So one for the robustness and resilience, and the other one for the innovation. And at the very beginning, that sometimes turns out to be an interesting approach and even functional working, because they have clearly separated areas on the playground and they don't have to interact too much, and they don't argue that are not in a conflict for some rare resources. But as soon as the innovation guy, the chief digital officer, has come up with a number of systems which are new and customer-oriented, based on new technologies, things like that. And he wants to implement them in the application landscape, not only as a prototype somewhere in a lab, but in the application landscape of the IT department. There's a conflict about, well, infrastructure resources, personal resources, resources of any kind. So now the conflict begins and things have to be sorted out. One of my colleagues from the University of Brussels just recently investigated in 32 pairs of CIOs and CDOs and came up with a conclusion after observing them for 2 years that at the very beginning of such a relationship, things are easy, clearly separated responsibilities, everybody running. And after a while, as soon as the innovation guy comes into the area of classical IT problems, conflicts are rising, and there are problems which also affects the overall working structure. And after a while, he talks about 2 years. I wouldn't take that really as a two-year perspective, but after a while, things have to be sorted out differently and things have to be reintegrated. Not two guys with being responsible for the resilient systems and for the innovative systems, but things have to be reintegrated somehow in order to resolve. Okay, so ambidextrous attitude now means that in an organization, we have to take care of both perspectives. Letting alone if the organization as CIO and CDO is the right organization way, at least we have to take care of both perspectives, robust systems and innovative systems. And both kinds of systems have to be developed, researched, operated, things like that. And that means an organization as a whole has to be able to work with both hands. That means that's the initial meaning of ambidexterity, with the left-hand side for the robust systems and with the right-hand side for the innovative system. And the organization as a whole has to come up with an organization pattern for this thing. At the very end, and that seems to be clear, as well as from the study I already mentioned, and as well also from the experiences at a number of customers, the organization form changes from one head of IT over the intermediate state of a CIO and CDO coexistence at the very end, and that's not done now in the most cases to a digitally ambidextrous organization. Well, so that's the organization issue of how to deal with IT in a responsible and innovative way. The second one is cloud native thinking and using the potential in the architecture of software systems and application landscapes. Also being on the marketing level here with this slide, sometimes it happens that you enter customers that have a number of arguments why moving their systems to a cloud infrastructure is not possible or more or less forbidden. If you talk to, in Germany at least, I don't want to generalize that, but in Germany, if you talk to small customers, if you talk to public administration customers, for instance, they have a number of concerns and they are based on a number of good arguments that cannot be done because privacy issues, security issues, and because sometimes it's simply forbidden to store the data in a not German or European-based infrastructure. So that's talking about cloud infrastructure, only about cloud infrastructure, and our demand is cloud native thinking. We don't want to convince people that they have to move to the cloud. Well, that's regular business. Yeah, that's not really interesting. But our concern and our demand is if you develop your systems, do not talk about cloud only. Have a look at if you develop your systems in a way that allows for cloud nativeness. So what the differences here that we want to look at. So cloud native describes the architectures, processes, and tools which we believe necessary to develop and operate applications that run flexibly and in an optimized way on elastic infrastructures. So not only running somewhere on different people's system, which you could call cloud-based, but to develop systems in a way that the original advantages of cloud infrastructures are exploited. So if you have a contract administration system and you know that at a particular point in time, for instance, in November, like for car insurance companies, things are changed dramatically because more or less all customers are looking for the new tariffs and quitting their contracts and going for new contracts at a different insurance company, then you know that at that particular point of time, you have to be prepared. You have to scale up your system. You don't have to have your infrastructure available for the rest of the year because it's a rather stable and flat business. But at that peak time, your cloud services in the car insurance administration services have to be scaled up. And if you develop such a system, or if you buy such a system as a car insurance company, then you have to take care of this particular application use case. Then you have to be aware, then you have to be prepared to scale up and of course also to scale down later on. But only for that particular use case. There may be other use cases which don't demand for cloud nativeness. And the demand in the cloud native thinking question is develop your systems in a way and buy systems which fulfill the appropriate requirements that go for exploiting these cloud native capabilities wherever your use cases demand for these cloud native capabilities, but only for these. So of course you could say, well, I develop my systems that they are cloud ready in each and any perspective for each and any service. Well, can be done, but that's most probably rather expensive. Anyway, as the experience is, and there's a number of studies about that, that cloud-based infrastructure is not by nature cheaper than an infrastructure operated by your own. But if you take care in cloud native application in the design for the particular requirements, then things are going on easily, and you also can go for exploiting cost factors. That was our demand for cloud native thinking. And of course, it's based on the idea that sooner or later, all relevant IT components will somehow be migrated to the cloud, and that the cloud strategy demands for general cloud issues, and in particular, cloud native strategy opens up for the advantages I mentioned. And of course, that boils down to software processes, application architectures, deployment issues, and general infrastructure issues, but that's not so relevant for us here, I guess. So, third element in this business. So if you come to a digital company, and I would say, of course, I hope you agree, that more or less all companies are digital companies. That is very obvious for insurance companies, once again, or banks, because they don't produce anything than information. So that is digital anyway. And in such a company, data is available because everything in the processes is based on data. There is nothing else produced. There is nothing else which is processed. So data is the only fuel. So here we can use this data for more than just business process administration and business process execution. But of course, and I hope that's of course, I hope you agree, but of course it is also true for other kinds of businesses. Here we have some knowledge about automotive companies, and they are not that digital like insurance companies, of course, because obviously they produce something else than just a piece of paper based on information, but they produce cars. But they have digital twins about everything going on. They have digital twins of the product as well as the factory. So in the end, such a company is also so much based on digital information, on data, that we can fairly say, well, it's a digital company as well. So if we have digital companies with all these data available, our approach and our demand is to say, well, then just use it. That sounds trivial, and you might say, well, companies should be clever enough to do that anyway. And of course, they are clever enough, but they are stuck in patterns of business processes and how to do their daily business that they did not always, to be careful, did not always manage the change to look at their data from a truly data-oriented perspective. They are still caught in the dimensions of events taking place, business processes being started, different numbers of people doing certain activities in predefined orders. They don't think in the potential of data. And that's what we demand in our third dimension of the new school of IT, to change that dramatically and radically, to say, well, a data-driven organization has to look at the data available and the potential these data have. In Europe, we also have a number of problems with different kinds of regulations, which might not be used to you here. Sorry for the German title, but it's a guidelines for an ethic-based development of trustworthy artificial intelligence solutions. That's only here in my talk to say, well, these issues, which could be understood as strong arguments for not behaving like a data-driven organization, are countered by official European studies, by national studies, whatever you're looking for. How to deal with transparency, how to deal with documentation, how to deal with revision, how to deal with ethics, all that is somehow sorted out. Nonetheless, in convincing particular customers in particular situations, in establishing our new school of IT, all these arguments have to be taken. They have to be presented and discussed in detail in order to ensure that these arguments are not accepted as killing arguments for not getting started. Because that's, of course, the most the most easy way to go on, to take a number of arguments, say why it shouldn't be possible to establish such a data-driven organization. And here we have a number of arguments to overcome these different kinds of arguments. So then we should look at different kinds of situations, what kind of role data plays. You will see two different dimensions. On the one hand, we have the data value on the y-axis. So data is fuel for operations, or data is a driver of growth. Data is a fuel for operations. That's true for basically all information systems. Of course, data is needed for doing these operations in these digital companies. But in most cases, these data are not understood as a driver of growth. But things are changing, because in a startup-based economy, or well, an economy which is increasingly also determined by startup business, and by in an area and in a situation where technology innovations are coming to the marketplace, people are more or less more and more ready to accept that data might be a driver of growth. That dealing with data is not only interesting for improving services to customer, which also could be understood as a driver of growth, but it's responsible and the basis of new services, new business models even, and for new market structures where some companies appear and some others disappear from the marketplace, so that data as a driver of growth is accepted as an important dimension. On the x-axis, we also have a different dimension. So here it's about data collaboration. Many companies are used to use their data internally, and they're very afraid of sharing data, because their data are their assets, and if someone else gets access to their data, it could be whatever dangerous and endangering their business success as a whole. And only slowly people are understanding that data collaboration and data sharing with partners can be organized in a way that it's useful for everybody. Let me give you an example. Even in such a not that suspicious area like sports, it's very difficult to talk about data sharing. If you talk to a football club, and our main customer and my favorite football club is Borussia Dortmund from my home city, and you talk to them about what could be done with your data, with the data of your scouts, with the data of your medicine department, which player is injured when, with your data from the actual matches, who plays, how long, how successful, what did he do on the field. And if you take together all this data, then that might be interesting to identify structure in your particular team, to identify weaknesses, and to give some recommendations what could be improved. They are so afraid of these data, which might be accessible to someone else, that we came up with an idea, with a platform where data are provided anonymously from a number of different football clubs, and that only structures in team setups are provided on a general basis, and only by integrating your local data into this overall data set, you get with these more sensitive, in access to these sensitive results. And that was foolproof. Yeah, that was very safe and secure in all dimensions, but we did not succeed because even in this domain of sports, or perhaps not even, but in this domain of sports, people were very reluctant to share their data, even that if the technical solution ensured that nobody else could take any benefit from data of other football clubs. So I'll just tell you this anecdote to say, well, even if it's so obvious that the data available internally is not enough for any reasonable analysis activity, people are sometimes very reluctant to share their data. So I think that here we also have a quite important academic field of research, how such a platform could be set up that is really based on very reliable mechanisms and very transparent mechanisms, which allow that no one gets access to other people's data, but where machine learned models or classification activities can be executed on the integrated set of data. That should be an interesting area for the future. So what means data mindedness now? So for me, data mindedness means that everyone, well, and I really mean everyone, in the business departments, in the application development, in operation sales, and whatever the important departments of a company might be, that everyone thinks in terms of benefits and services and business models on the basis of available or procurable data. That means starting in this data thinking is a change in mind and is not only a technical issue. Our approach in the meantime is as follows. We set up prototypes of simple use cases of data-driven systems and services. Explain to all people in a company what this is, how it has been developed, what the benefits are. And then it's still not enough. Then you have to go on for a longer period of time with all elements of a proper and systematic change management in order to ensure that people get sticked on, and that this data-minded ideas get sticky in people's minds in order to ensure that everybody thinks about the potential of data more or less on a daily basis. What we actually did, for instance, in a number of situations, might remind you of what's done in Agile. Yeah? We did a daily data stand-up where people from different departments come together and discuss about what can we do with our data. And it's not really sorted out by doing this once or twice. Our belief and our change management people tell it has to be done over a longer period of time in order to ensure that change actually takes place. So doing that in a longer time and changing the data perspective from a simple data warehouse, what people are familiar with, to machine learnable data lakes, and also taking care of the data sourcing perspective, which, if successful, yields in data ecosystems, things are changing slowly. Having a look at these data ecosystems, where on an integrated set of data coming from different players, services are set up and provided to customers of different natures. The literature tells us that there is some sort of approaches how to engineer ecosystems. To my experience, it is complete nonsense. I believe that ecosystems are not engineered, but they they are discovered or they come into life incrementally, but not on the basis of a predefined blueprint. So it's really a question of emergent ecosystems. They emerge while being operated. And sometimes people have great ideas about these ecosystems and they just don't work at all because there are some missing links or the demand and the request side are not properly managed step by step. So ecosystem engineering sounds like a great idea. I'm not convinced that we have any approach now that really allows to do so. Okay, so what can be done to nonetheless get started? That's, well, a consultancy business more or less, to identify the right use cases. It's a whatever way. I don't want to go into the details of that slide, but the key message is start with the right use cases. If you want to implement a data mindedness in a company or only in the department, whatever, the general understanding that it's useful to do so can be gained quickly. The very initial simple use case can be installed easily as well. The step from there to a really data-driven company is difficult. And the main step in doing so, and the main instrument in doing so, should be to identify use cases which provide quick wins and easy access to growth in terms of customer or business, and a number of other dimensions which are given here, but which I don't want to discuss in detail for the next minutes. All that is basically centered around the questions, is it worthwhile to set up a data platform? And here we see also two different perspectives in industry. The very big customers, they are ready to accept some infrastructure cost and projects to say, well, let's set up a data platform where we integrate our data to some extent and make them accessible to different kinds of services from machine learning or artificial intelligence. But of course, that really is pre-invest in infrastructure. And generally speaking, people must believe in the long-term benefits of that. Sometimes it's easier to get started with just one use case based on his particular data and to go on for the next use cases later on and to develop the idea of a data platform only step by step. But whatever you do, if it's an incremental data platform or if it's a set up at once data platform later on, and that's a solution to this iterative and balanced approach, start up with implementing use cases as soon as possible. Longer data platform projects without use cases working on this data tend to be disappointing to sponsors of any kind. So data platform, yes, but starting with use cases immediately as well seems to be a good recommendation, at least for the customers we were talking with. Let me talk about some use cases that might be interesting. One was in the context of natural language generation, which is easy for, of course, if you say, well, it's a GPT-3 model and that's available for English. Yes, well, for English, it's available at least. We had to learn that for a number of European languages, for very precisely defined use cases like shortening texts, taking a text and saying, well, I want to have this text with this content, but in length of only 60%, something like that. Shouldn't be much shorter, then it doesn't work anymore. But down to 50%, it works quite good. And we had, of course, it's always the same problem. Here it's with a publishing company. It's always the same problem to get access to enough data. And here we were lucky because it was a big German publishing house, which a number of daily newspapers published all over Europe, not all over Europe, but in a number of European countries. And the texts and publications they had were of a certain quality. They were written by journalists and corrected and things like that. So it was correct text. And from this correct text, we were able to learn. Well, our model was able to learn. And that took quite a bit of resources in terms of CPU and bandwidth in telecommunications, but it turned out to come up with a GPT-3 similar model in German, and that worked for developing shorter text from longer text, which was very interesting to journalists, because they do not only publish in a newspaper, but they also have the activity of, well, provide some information to our social media channels. And for a social media channel, even a short text in a daily newspaper must be shortened once again. And a headline must be produced, for instance. That also is one of these use cases here. And perhaps a picture has to be, a photography has to be inserted somehow. And all that turned out only by this GPT-3 model. And it was based on the availability of these data on a broader scale. But the journalists were skeptic about that at the very beginning. You can imagine that easily, because, well, that's their most prominent task, to write text, and to tell them, well, that could be at least substantially supported, if not automated, was quite a difficult thing to communicate. But well, it's in place, and on the workplaces of these journalists now for a while, and that works nicely. Okay, then we have my all-time favorite football example. Artificial intelligence and machine learning in football. The initial use case was to say, I just want to stream football in lower leagues. That does not apply to Bundesliga or Premier League or whatever, not these top leagues, not even for the top 3 leagues in all these different markets. But below of that, we have a number of football matches taking place. In Germany, for instance, we have some 25,000 football clubs, and they are playing football at each and any weekend, except of summer and winter break. So an incredible amount of streaming information. And not for each of these matches, a camera guy is available who takes a perfect and right stream, but it should be automated. And so some guys in a startup business developed a camera that does the camera zoom and the camera steering automatically based on neural networks. And that turned out to be interesting for just streaming. That was the initial use case. Taking a stream, but of course you cannot watch 90 minutes total, but you have to have a closer look on what's going on, where the ball is, and where the real business is on a football playground. And then, of course, there were a number of additional use cases which came up with appetite after showing what is possible with the streaming perspective, because football clubs wanted to know, well, can I have that stream, and can I identify my highlights? Can I identify who is on his position, who is not on his position? Can I measure who is running, how far, who is doing how much tacklings, and how often does he have contacts with ball and opponents? So quite a number of interesting information still on the lower league business. And then it took the next perspective to higher leagues, which is not implemented yet, but under operations, because someone says, well, if you have information about the situation of the ball and the information of all the players, and you can zoom in more or less arbitrarily, can't you check how precisely the ball is hit by our different players, and what is he doing correctly and what could be improved? So that is obviously an artificial intelligence, well, machine learning based system, which is operated in the real world on the playground. And so it's a cyber physical system to some extent, and it's also based on telecommunication infrastructure, at least for the streaming onto different kinds of devices of viewers. So quite an interesting application case. We have another one, identification of tooth anomalies. I didn't imagine to publish in a journal of dental somewhat, which we recently did, because it could be proved that based on the number of pictures of teeth the identification of early stages of dental caries could be done better than by doctors themselves. And I did not believe in that because, well, I thought that a doctor should be more trustworthy than such a camera. But after training it on enough pictures, the algorithms turned out to be better than a doctor, which was published here, and it was done with experts from the field. So I believe that was really a good example. So what did we learn by these examples, by a number of different other examples? We learned that the software process is different, that we do not only have the DevOps challenge, but we have an ML DevOps challenge, where most of our time is spent on finding the right data, preparing the data for machine learning, and that really takes some effort and is difficult from a traditional software development process. We also learned that we need different kinds of people. We do not only need requirement engineers and architects and software developers and quality management guys, but in the very early field of identifying the right data model and identifying and providing the right data, we need domain experts. That's something we really learned by heart and in the hard way. Don't try to develop such a system, a machine learning based system in any application domain, if you don't have real access to application domain experts. That is true for, well, each and any kind of software development to some extent, but I think here it's even more important. Without domain expert, well, it's just a question of risk and chance, and I think generally the risk of doing that is too high. Of course, you have data, you have to integrate data scientists and data domain experts. But meanwhile, we believe that an ML expert for preparing the continuous integration and delivery pipeline is also a worthwhile ingredient, which could be done by the software engineer perhaps. But there are a number of particular activities in this data field which demand for new qualification and new roles in the process. I think I can skip that, and that is in the slides. What we also learned is that coding is less important. Of course, it's less important, but for a software engineer like me, and also for a number of software developers in companies and also researchers in software engineering, that is a difficult and hard finding. You don't provide that much data anymore like you do in developing an information system. You have to take care of data collection, feature extraction, data verification, all that. But the real coding issue is really much less. It's a simple no, it's not a simple activity. It's a difficult activity, but it doesn't take too much effort. So it's difficult from both sides of the coin. It's not that much, but it's difficult. And people doing that are really rare because they are so short activities in doing that, so little effort spent on that. The community of people who really has sufficient experience is rather small. That makes it so difficult to integrate these people into your teams. So requirements engineering is different. New requirements always can be implemented in information systems. In these integrated systems of cyber physical and data engineered systems, you do not always know that the quality and amount of data is sufficient and that information is available in this data. So feasibility questions with respect to accuracy and precision cannot always be answered in advance. And for traditional managers, IT managers, that's quite a challenge because they have to be confronted with the idea and with the finding that in dealing with big amounts of data, one of the possible results is that there's no information in this data, that it's just data. Not always, of course, not even in the most cases, but that it can happen is a challenge to many of these guys. Okay, so testing and evaluation is different and is more difficult, I believe. So if you have a model, a machine learned model, how do you operate it in the real world, in a changing real world, and what do you do with exogenous factors which demand for continuous learning, for an adaptation and an auto learning? That all these things have to be sorted out. And they once again raise the questions which we had at the very beginning about transparency, trustworthiness, confidence, and ethic development of these systems. As soon as the system starts to be adapted automatically, they have to be, all these questions have to be discussed on a regular basis and on a periodic basis at least. So I think I can skip that, how we attack these approaches to identify the right use cases, since that's more or less clear. On the way to the new school of IT, that was our main finding at the very beginning. It's important to acquire and maintain new skills and competencies, that you have deep respect of domain expertise and innovation spirit, and that you anchor the following roles like Chief Digital Officer, Chief Data Officer, and Chief Cloud Officer in an organizational structure. And in software processes, and that's my main domain as software engineer, you have to anchor BIS DevOps, ML DevOps, DevOps pipelines, data pipelines, perhaps also what I skipped, interaction rooms, to identify the right use cases at the right time. And that only these 4 elements on the headline level are difficult to do in an existing organization. That means to implement a new school of IT role model in an existing infrastructure, together with the approach and the ambition to implement something like a data-driven organization as a key element of the new school of IT, is really difficult and cannot be done at the side of some other project. So the idea to say, well, we have to do some projects anyway, and we introduce this new school of IT on an extra lane, but well, we don't have to focus it, is definitely not a recommendable approach. So my conclusion to that is that the new school of IT, and perhaps it's not true to say it's a new school of IT. That came to my mind in looking at my presentation yesterday. Perhaps it's simply a new school of information. Perhaps it's not a school of information technology, just a new school of information, because that really shows that it's not an IT issue, not an issue of IT departments on their own or on its own, but that it's an issue of the business as a whole. And the whole business has to take care of information. Perhaps it's a new school of information. At least it's a full-fledged framework for organizational issues, and it should enable a fundamental shift of the notion of IT and the role of IT. And from my understanding, for the first time in history, IT is now systematically linked to business innovation and business benefits. And that's perhaps simply and only due to the number of innovations we have to deal with, and to the understanding of people that they cannot handle these innovation potentials step by step, but that they have to look on them in an integrated way. And perhaps that's our chance now to say, well, new school of IT is what IT departments needs and what the research in universities could be also focused on. Thanks for your attention.
Thank you, Volker. We have some time for questions from the audience. Yes. Yes.
Hello, Professor. Guten Tag. Anil Patel from Keynote. Thank you. Very insightful and very thoughtful presentation on New School of IT. My question is, there is another kind of approach in the direction of continuous engineering. A concrete example would be FSD beta version from Tesla, where they collect data from surrounding environment and they process those data on neural network and they put it on safety critical system. Do you see such approach is a correct way to address challenges what we had right now? And where do you see the problem in this kind of approach? That's all. Thank you.
So I think to some extent it relates to this new school of IT perspectives, because it works precisely on integrating all data available and evaluating them continuously. I think that's a reasonable approach. But of course, there are really some extra challenges on what that may mean for the final products of cars, for instance, yeah? Because there are some ethic questions which have to be taken careful and have to be answered carefully. But the principal approach is that, well, we integrate this data on an integrated and continuous basis and check what use cases could be set up on that seems very reasonable to me.
Okay. Yeah, because there was another example you talked about, this dental operations where you took some of the samples of photos and then you process on those data points. Is it also influenced how much, how let's say a number of samples you took for the training and testing? So the larger the number of data sets, the model would be better or something?
Sure, sure. Yeah. You always have too few data, yeah? And to check carefully if there is any bias in this data and how they are separated is a key question in the data preparation activity, of course.
Yeah, yeah. And there's always uncertainty influence, like garbage data kind of in the data set goes in, and
of course,
on decision on it.
Yeah. Of course. So I'm saying the more effort you spend on acquiring data and preparing data, the less noise is in the remaining data, of course. But to some extent, a level of noise has to be accepted and is really needed, because real world data, which are evaluated later in operating such a model, is a phenomenon that cannot be abstracted away. So to keep the data and the data separation as close as possible to what's going on later, to the quality and amount of data which has to be analyzed and processed, is a key question.
Thank you, Professor.
Is there any question, comment? Yes.
Thank you for the presentation, Professor. In the first part of your presentation, you mentioned data collaboration, European data spaces, and European issues with ethics and data privacy. Do you have any experience or insights about federated learning and how it can help or influence data collaboration?
Federated learning, did you say federated learning? Okay. So I think federated learning is one of the application domains which is addressed by the Gaia X initiatives, where they look for data from different application domains, but also on a federated learning by the different suppliers. But, and that's an important but, I think the Gaia X issues are more or less on a concept-aware level. It's not yet implemented. So I think the mechanisms and services provided in these concepts are also interesting to see how federated learning could take place. I didn't see any, not even prototypic implementation of that.
Yes, that's exactly why I asked the question. The federated learning is not yet production ready, as far as I know. I was just wondering if you had any behind the scenes information.
Yeah, same impression here.
No, thank you.
Someone else question last. Volker, thank you so much. I have some comment or observation about the things here in terms of integrating machine learning with software engineering. And I think the most crucial part is the data. So I think it's very important to provide some sort of, we call it data bank, that you trust the data when you use it for engineering. And this is perspective become very important, especially with recent machine learning in terms of security using in governmental institution, blockchain, and so on. So I wonder why this was not. You mentioned about ethics in one slide, but you didn't explore this in your talk. Can you give me some sort of comment on what I'm saying?
Yeah. So I think the use cases we are dealing with on a daily basis are those of the lowest category of the simplest use case anyway. It's just based on processing data sets in order to recommend and provide some assistance to people participating and taking the final decision. So as long as we deal with these use cases, I think ethics has to be considered, but is not that crucial. As soon as we start to automate decisions which affect people individually or as a group, things are looking differently, of course. And in that case, the guidelines I presented may not even be sufficient. They also have to, in that case, we have to integrate ethics committees like we have them at our universities, for instance. All of us have these. But I think in the simple cases, which cover 80–90% of what people are doing now, things can be handled easily.
I hope so. Yeah.
Yeah.
Well, it's a very stimulated talk. I think there are a lot of things. I was wondering on only one last comment about the term of using school in your talk.
Mm-hmm.
And school means some sort of entities that bridge a sort of a new paradigm for education or teaching people of a new directions. So the school here, you see, we have a lot of old topics in education.
Oh yeah, so do we.
And still machine learning perspective and teaching is not in the level, is related mainly to artificial intelligence related topic, but not in software engineering. Mm-hmm. So probably this is a new direction. I wonder about SN if you have a new kind of subject that you are teaching or university is directed in that move.
Yeah, so we recently set up a new bachelor studies it's only software engineers. Yeah, so in the new School of IT is not in any sort of title, but I took care that the contents is in. So they are talking about machine learning, they are talking about cloud natives, about application management in a much more modern way than the old bachelor was organized.
Yeah, that's very exciting. Anyway, thank you so much, Volker. And I will send you this.
Oh yeah, great.
Thing by post.
Thank you very much.
I send a copy on WhatsApp for you.
Great.
So I hope I can bring it in myself.
Yeah. So if you're in Granada at the end of the year, just let me know. Perhaps I come over, then we can meet.
Wow, that's beautiful. Then we can have a nice beer together. I miss that. It's Spanish beer, not German beer.
Yeah. Would be great.
Thank you, Volker, again, and on behalf of all the members here, I appreciate
Thank you very much. Thanks for your interest. Thank you. Goodbye.
Okay. Have a nice day. Okay. So, thank you very much again for